and Development, and the Indian Financial Management Association. He has contributed number of research articles in various Indian and international journals. He has few research-based books to his credit. He also guided a number of research students. It's an honor and privilege to have you here with us, sir.
Thank you, Anshika.
Thank
Thank
you,
you for
sir.
the nice introduction. Okay, so I hope everything is set, the volume and the audio and the video.
Yes, sir.
Yes,
And
sir.
Yes, sir.
you
Yes,
are
sir.
able to see my screen also?
Yes, sir.
Yes, sir.
Great. So, friends, let's start. And good morning to all of you. And welcome that you people are here and joining this particular session. Thank you very much for being with us in this morning. So, some words I would like to share with you about econometrics. It says, science of econometrics never proves anything. It only disproves or fails to disprove. Please understand it. That's very, very important message for every researcher. Econometrics never proves anything. Either it disproves whatever research hypothesis you have, whatever hypothesis you have made in your research, either you will disprove those hypotheses or you may not be able to disprove them. But we never prove anything by making use of econometrics modeling. That proof has to come from your argument, that proof has to come from your underlying logic and theory. So friends, be clear about it. You can prove or disprove. You can you can disprove or you can fail to disprove. But you cannot prove by making use of econometrics. Okay. In fact, somebody has rightly said, econometrics bring theory to the ground. That means whatever theories are being developed, those theories have been tested and put forward before the people and before the public. So friends, with these words, let's move forward and have a quick look what we discussed so far in time series. The very first day, we try to understand what is time series and its behavior, hologram and autocorrelation and partial autocorrelation. We also try to understand the concept of stationarity, weak and strong stationarity. We also understand the concept of unit root and test of stationarity. And yesterday you talked about how to how to forecast mean through ARIMA and how to forecast volatility by using Arch and Garch and similar models. So these are the things which okay. So friends, I'm getting a question. Can we use technical analysis tools as input for ARIMA? I do not know which tools you're talking about. Are you talking about RSI or you're talking about MACD, or I do not know. But share prices, share returns, volume data, you can take as an input for econometric modeling. And ARIMA will like to predict that. Okay, estimations are not predicted by econometric modeling. Only the actual data will be predicted, because the estimate which we get are not that generated by a random process. It is generated by a well-defined process, deterministic process. Okay. Somebody's asking that how can you do when you have future forecasting? It gives you any. Uh, uh, Friend, you have to first create your data series up to a future point of time. And once that series is created, then you can have the prediction for the future. So you have to change the data range, and then you can have a prediction. Otherwise, you may not have a prediction. Abba is asking, can we have dummy variables in Garth model? Yes, you can have dummy variables. That's not a problem. Okay, and how long can we forecast horizon of ARIMA and uh, one thing, let me tell you, I'm not going to repeat what has been done yesterday, because if I start repeating it, I cannot cover what we are going to talk about today. Okay, ARIMA gives you forecasting, and that's for the future. Okay, and it doesn't make a sense that you should have a very long uh, prediction about future. And I do not know whether you people are aware of it not. Many of the time series are showing chaotic behavior, and one of the basic principle of the chaos theory is that the you cannot have a long run meaningful predictions, but you can have meaningful predictions in near future. Okay, so I don't suggest that you go for a very long future forecast, and because you may get some information in between. That new information can help you in getting further or future forecasts. Okay. Friends, a lot of questions are coming about what we have discussed yesterday, and because they are very some of them are really technical, and to answer those questions I have to go into detail of the estimation process. So friends, I'm really sorry, I may not be able to take all the queries about arch, garch, e-garch, t-garch, or any other model of the garch. Okay. That model can also be run by making use of dummy variable. That's not an issue, but that dummy variable should be as independent variable. Okay. Uh, Dr. Ganpati is asking that before checking for causality, what are the prerequisite that we are going to talk about in this particular session. So just wait, you will get answer for that question. Okay, so Ambinder Singh is asking me, can we explain the difference between drift and trend? Uh, a series with a series that is having a drift will have a trend, and that trend will be stochastic trend, because you will find that the change in y is equal to the drift alpha plus error term, which is random. Okay, so presence of drift in a stochastic process will give you trend, no doubt about it, but that trend will not be deterministic. That trend will be stochastic in nature. Uh, Sonalika is asking me how do we get an idea about intercept and trend. For that, you have to make a graph, and graph will give you a hint whether the series is having trend or not. So, for example, return data, which behaves like this, doesn't have a trend, but returns can never be zero. Okay, on an average, returns has to be some positive number, therefore it should have an intercept. On the other end, if you see the price data, that looks like this, which is having a trend as well as intercept. So by looking at the graph, you can get an idea whether the series is having trend and intercept. Uh, Marvin is asking negative coefficients in Gauge equation may create a problem. Yes, because that may result into negative value of variance. So be careful about it. You have to ensure that all coefficients are positive so that the resultant value of variance will always be positive. Uh, When I say lag 2, that means I'm taking, suppose I have data of 1970, 71, 72, 73, like this. Then a series with the lag 2 will mean 72, 73, yes. When I take a leg, I'm not taking a difference. I'm just adjusting up and down the time series. But when you take a difference, you take a yt minus yt minus 1. That's delta y, and that's your difference. If you take again difference of the delta y, that is the second difference. Okay, so I hope you are able to understand that. Uh, Negative r square could be possible, but normally it's not. Negative r square means the model is not a correct model, and you have to redefine your model or relook at your data so that you can come out with the proper model. Any model with negative r square is not acceptable at all. Please rework on it, either in terms of the data or in terms of the definition of the variables or in terms of the new model. Okay. Please understand white noise is nothing but your error term. So you can estimate error term and that will give you white noise in the system. Uh, Dr. Vijay is asking what about the diagnostic techniques? Diagnostic techniques means whatever assumptions you have made in a particular model, you have to test that model so that you can say that your model is a correct model. So for example, if I'm using OLS, sorry, if you're using OLS is making certain assumptions like normality of the error term, no autocorrelation, like this. So when you go for diagnostic test, you have to check whether these assumptions are true or not. For that, you have to make use of suitable diagnostic test depending upon your model. Uh, Collagen is asking me a question that should we take larger data to get better estimates? Uh, well, look, I will not say that you should go for a longer series to make sense, because what happens, say if I take a data from 1950 to 2020, you will find that there are a lot of changes in between, policy changes, structural changes, and because of those changes, the behavior of the data is totally different. And those policy changes may not be relevant now. So you have to be careful about it. Okay, and take that data where you find that you don't have much policy changes, so that you can extend the inferences from that data to the future. Okay, so taking long-term data in some cases makes sense, but when you have data with a lot of policy changes, structural changes, changes in the regime, then very, very long data may not help you in analysis. Margaret is asking, if you study a fund for the 5 years, will there be problem? I don't think there will be problem if you take their daily net asset value or weekly net asset value. But if you take annual data, then you will be having 5 figures. That will not make much sense. Okay, so 5 years data is okay, but as long as you take a proper frequency of the data. Okay. Uh, Ankit is asking me about the reduction of PSC in ME. And friends, I give you one statement. Please listen it carefully. Every moving average process is a stationary process. And if it is a stationary process, then you will find that it doesn't have a memory. It will fade out over a period of time. Okay, so that is an important concept you have to understand. Every moving average process is stationary. Okay. Uh, Even methodology, etc. I think Anjali will be the best to ask, because she has worked a lot of research in the event methodology, so she can help you in telling you where you can make use of event methodology and how can you make use of methodology. For paucity of the time, I'm sorry, I may not be able to answer it, but you just talk to Anjali. She will definitely answer your queries about event methodology, whatever queries you have about it. Okay, friends, now let's go ahead. So far, so good. And hopefully, you people are learning and getting a feeling about what time series, what we can do with the time series data. But don't forget, you have to understand. That's very, very important. Don't leave the things as a black box. Go deeper into it, dig into it, get a feel of it, become confident about it, and that's possible when you start understanding the things. Okay? Let's see what is the next we are going to talk about. Moving it from the world of univariate word to multivariate word. So far we were concentrated talking about one time series. Now we are going to more realistic scenario where we don't have one time series. We have a number of time series and we are working with those series simultaneously. Okay? Right. Like here, Till now, yesterday and before yesterday, you were having a one time series. Now we are taking a number of time series, and that's why I said we are moving from the world of univariate to the world of multivariate. So now let's start studying more than one series simultaneously. Okay. Uh, Purushottam, is audio is not clear,
Audio is clear, sir,
It is
but
clear, sir.
but somebody are saying that there is a problem in the audio. Okay, just a second.
some disturbance may comes in background sounds as background sounds. Otherwise, the audio is pure clear, sir.
Okay. So why we are moving from univariate to multivariate? What is the motivation behind it? Why should you work with multiple time series rather than one time series? We should have a reason for it, the motivation for it. And the motivation is usually believes that everything depends on everything else. So it might be possible that series YT may be a function of another series XT. And if these functional relations are there, then you can appreciate their relationship better and you can have a better forecast. Okay, if you have only one series, you may not be able to take the advantage of information that is there in the other series. Okay, let me explain what I mean by this. You have a series, let's call it series of BSc Sensex, and let's assume that we have a series of share prices of Infosys, or you can take prices of, say, you can have the inflation data, you can have GDP data, anything else. Okay, I want to forecast, say, Infosys prices. So one option is you forget about what's happening in the market and take one series, make a forecast. But friends, it may be possible that if you take market data along with the Infosys data, you may be able to get a better forecast. It might be possible. Okay? Right? Another thing is, say, I want to predict GDP of a particular country. So one option is I take GDP series predicted. Then I get inflation data. Can I use this inflation data to get a better prediction of GDP? You may say yes. If it is so, then you have a motivation for going for multivariate or multiple time series data rather than univariate time series data. Okay, so there are interdependencies which can be exploited from generating information to have better forecasts, better estimates, and better establishing better relations. So friend, that's the motivation for going for multiple series. Okay, so the motivation is exploit the information in other series, and that's the reason we are moving from one time series to more than one time series. So friends, I hope motivation is clear to you. Once we have multiple time series, the challenge is how to model that. Okay, so far we were talking about one time series. Now we are having a number of time series, and we have a challenge what to do with those time series, how to model them, and what we can get out of these multiple series. You can do a lot of things in it, but in this session, I'm going to talk about what is called Granger causality between series. Okay, co-integration and other things you can discuss in other sessions. Okay, but don't undermine the importance of multiple time series in your analysis. So we have multiple time series data with us. What approach we should go ahead to model the time series data? So usually we follow any one of the approach. One is called the bottom-up approach and another is called a top-down approach. And you might be wondering what this approach is all about. Okay, suppose there are two series xt and yt, and I'm studying a relationship whether there is a cause and effect relationship between xt and yt. Okay, you want to check it, you want to prove it, you want to test it whether there is some kind of a cause and effect relationship exists between xt and yt. How to go about it? There are two options. Option number one, you assume there is no relation. Okay, and then you prove there is a relation. Another approach is you presume there is a relation, and then you test whether, then you prove that there is no relation. I repeat what I'm saying again. There are two ways to handle it. Cause and effect relationship between xt and yt. I do not know what is cause, what is effect. I want to check it. One assumption is that there is no relation. Another assumption is there is a relation. And then you test accordingly. Okay, so these are the two ways through which you can proceed in your analysis for testing cause and effect relation between the variables. And accordingly we get two approaches, bottom-up approach and top-down approach. Following a bottom-up approach or strategy, we first assume, understand that, we first assume data generating processes of the different time series are independent of each other. That means no relation. And in a second step, we ask whether some specific time series are related to each other. This statistical approach was suggested by Granger and is today usually employed when we go for causality test. Okay, that's what we have a bottom-up approach. Let's see what we have in a top-down approach. Top-down approach assume that generating processes are not independent. That means there's a relationship. And in a second step, we ask ourselves some specific time series are generated independently of the other time series or not. And this approach is pursued when we go for vector autoregressive process, which in short is called VAR, vector autoregressive process. What is it that we are going to talk about a little later? Okay, and both approaches are employed to investigate the causal relationship which potentially exists between different time series. It's your choice. You can adopt any approach for establishing cause and effect relationship. So friends, I hope you are able to appreciate the way you can proceed further for determining cause and effect relationship between series. So first, we go for bottom-up approach. Okay, so our all fight is how to know the cause of something about which you are going to do research. And we have a very famous quote that says, everything has a cause, and the cause of anything is everything. So be careful. If there is something that exists, there has to be some reason behind it. And as a researcher, many times you're curious to know whether there is some reason at the back of a particular phenomena which is reflected by a time series. Okay? So friends, enjoy this snowfall. You might be wondering why I'm talking about snowfall, but I have some interesting questions about snowfall. So friends, the purpose of showing this to you is as follows. As a researcher, we have a question here. Is it a fall in temperature that causes snowfall, or is it snowfall that causes temperature to fall? Okay. I do not know how many of you are from hilly areas. Can any one of you answer what is the cause of snowfall? Is it the fall in temperature, or it is the snowfall that is responsible for fall in temperature? Uh, Many of you are saying fall in temperature is the cause. Okay, right. Now I am in Delhi, and whenever we hear that Shimla is having snowfall, that means we expect that temperature of Delhi is going to fall. Don't you believe that? Daily temperature is the result, reduction in the daily temperature may be the result of snowfall on the hills. So in that case, you may also say that temperature, snowfall may lead to fall in temperature. So what is the right cause and effect? As a researcher, you have to take a decision about it. But there is a cause and there is a effect. Okay. And what is that? How do we understand that? How do we identify them? That's one of the biggest challenge before a researcher. Friends, let me share with you another slide. Now, in this regard, I have a question. Is it lightning that causes thunder, or is it thunder that causes lightning? Or both are happening simultaneously, or both are happening one after the other? I mean, that's, as a researcher, I'm curious to know it. We all know that if you have clouds with a negative charge and a positive charge, when they come closer, lightning take place. Okay, and scientists are saying that lightning and thunder happens simultaneously. But we hear thunder after some time, uh, after we see the lightning. Okay, so if you want to study a proper cause and effect relationship between variables, then you must understand what is a cause and what is an effect. Can I say thunder is a cause, lightning is an effect? Or can I say lightning is a cause or thunder is an effect? Can I say both are causes, both are effect? I do not know. As a researcher, many times we do not know these questions, but you have to know those questions. As a researcher, you have to find answers for those questions. What is causing what? Okay, so that's the mystery which we have to understand, the mystery behind cause and effect. When one event causes another to happen, the cause is why something is happening, and the effect is what happens. There was a question about NSE. The index is causing impact on the reliance, or reliance is impacting index. I do not know so far, but we have the data with us. We will check what is causing what. Okay. So, friends, let's have a discussion on devote some time on cause and effect. Okay, a cause could create a new thing or change the existing thing or the system. So when X is changing Y or creating Y, then I can say X is the cause, Y is the effect. Causality means one thing which is called cause under certain conditions gives rise to or causes something else which is called the effect. The essence of causality is generation and determination of one phenomena by another. So what we determine is called the effect, and what is being determined by another, that is your cause. Another thing we have to appreciate is cause always precedes effect. That's also a thinking about cause and effect. Okay, but many times you'll find cause and effects are happening simultaneously. They are going parallel also. Okay, right? Past events are causes of future events, but future events can never be the cause of events of the past. Please understand it, appreciate it. If we are working with the time series, future cannot predict past, but past can predict future. Okay, so these are some of the thoughts about cause and effect relationship. Now let's see how do we understand the logic of cause and effect in time series context. Okay, and in fact that takes us to the concept of Granger causality. A variable x would be causal to variable y if x could be interpreted as the cause of y and or y as the effect of x. So cause is giving you an answer of why something is happening, and effect is what has happened. Okay, so cause gives birth to an effect. That's what we look at as a causality. From where do we get the necessary information for our econometric models to establish cause and effect relationship? For cross-sectional data, it is the theory which provide us necessary information about cause and effect relationship. So whenever you are working with the cross-sectional data, you have to refer to the theory that says this should be a dependent variable and this should be an independent variable. Independent variables are causes and dependent variable is the effect. But what about time series analysis. How do we, look at the causality in the context of time series data? For time series, we take information from the concept of what is called a Granger causality for determining causality. And now let's see what Granger causality means. Concept is based on the premise that cause always precedes effect. Understand that. That the basic crux of the philosophy of Granger causality. Cause is presumed to be occurring earlier than effect. It means that the concept of Granger causality is related to idea of succession in time. That is t, t plus 1, t plus 2, and so on. So what's happening at t affects t plus 1, then I can say cause and effect relationship. It means that on a timeline, if an event X happens before the other variable Y, then we say X Granger causes Y. Please mind my language and listen my language carefully. I'm not saying X is causing Y. I'm saying X Granger causes Y, because I am only conveying a fact that this is happening before, X is happening before Y. Okay? If XT improves the forecasting performance of YT, then XT Granger causes YT. Suppose you have a ARIMA model, right? And say ARIMA 1, 1. So you say YT is equal to alpha plus YT minus 1 plus error term T minus 1 plus ET. Okay. This I'm predicting only with the information of Y series. If I add into it xt minus 1, for example, then is inclusion of X series in my predicting model improve the prediction of YT? If you say yes, it improves, that means X is Granger causing Y. Please understand that. Okay. If XT does not improve the forecasting performance of YT, then XT does not Granger cause YT. So friends, I hope you are able to appreciate the concept of Granger causality. If X and Y are happening simultaneously, in that, say, for example, if I take an example, XT causing YT and XT is also caused by YT, then we say the system is having a feedback mechanism. Both are both are causes and both are effect of each other. Okay, more of it I am going to discuss later on. Okay, I'm taking two questions. One is by Vinay Singhal and another by Ankita Akalia. Uh, Vijay is asking for a practical uh, for a practical example. Say for a see 28th say let me take a company announces its quarterly result on say 15th July 2020. And the moment the result is being announced, then we find there is an impact on share prices. Then I can say quarterly result is Granger causing YT. Okay, that's what it means. Okay, I hope this is clear to you. If something happens before, like if you switch on your electricity uh, switch, then you will find your fan is on, fan is working. Then I can say switching on is cause and the running of the fan is effect of it. And if you put it on a timeline, then the event of switching on is happening before and working of the fan is working later on. So I can say Granger causes switching on is having Granger causes the functioning of or working of a fan. Okay, friends, another important question uh, from Ankita. If you say X, Granger causes Y, and X causes Y, then is there a difference? Uh, I do not know. Can any one of you try to have a guess about it? Difference between X causes Y and X Granger causes Y. Amar Singh is asking me, can we check causality in GDP, foreign equity, foreign debt, FDI? Yes, you can do that. No problem in it. Okay, right. Let me take an example. Suppose I have taken cross-sectional data of income of the people and consumption of the people. Same period, same point of time. Okay, so I get income, I get consumption, and we find that consumption is a function of income. That means Y is causing consumption, but Y is not having Granger causality with the consumption. Understand that. Granger causality always presume that there is a timeline, but causality may not assume a timeline. That something which you have to appreciate. Okay. Another thing is if X is happening before Y, it doesn't mean that Y is because of X. It may be because of something else. It may be because of something different. So, for example, stock market changing. There is a change in the stock market today, and tomorrow there is a change in a share price of company X. So I can say that stock market Granger causing Y. But why tomorrow X is changing share price? I do not know. That may be because of imposition of import duty. which is impacting the market, which is impacting this. So this is the cause and these are the effects. The only thing is that one effect is happening before than the other. Okay, let me take another example to show you what I mean by Granger causality and how it is different from cause and effect relationship. Suppose I take spot prices of gold in India, future prices of gold in India. Okay, and let's assume that future market is more efficient than spot market. So change in future market take place before change in spot. Please understand the implication of these words. Change in future market takes place before the changes in the spot market. Okay? Government bans import of gold. Okay? Now you can say this is the cause which will impact your future prices and your spot prices of the gold. So I can say import is the import or ban on the import of the gold is the cause and it's causing the impact on the spot prices and the future prices. But if I do not know this, I have only spot data and the future data. And I see that future is happening before, impact on future is happening before, and then spot, then I will use the terminology future Granger causes spot. Friends, I think now you can appreciate clearly what is the difference between X causing Y or X is Granger causing Y. Just let me give you one crude example which will make the things more clear to you. We all know that during the festival season, that during the Dussehra, Diwali season, sales are picking up. So every year, what we assume that sales are picking up, and after that, Diwali happens. Sales are picking up. After that, Diwali is happening. So increase in sales is happening first, and then Diwali. Increase in first, then Diwali. Then in terms of Granger causality, I can say that sales is Granger causing Diwali, but sales are not causing Diwali. Understand that difference between the cause and effect in terms of the true cause effect relationship. Okay. Sorry. Okay. Uh, Panel data, if you take the uh, time series and not the cross-sectional, then you can apply the Granger causality, otherwise you cannot. Precisely, Granger causality means past values of X help to explain Y. Then we say X Granger causes Y. It's a statistical concept and does not give you the true cause and effect relationship, and that will come from theory. A lack of Granger causality does not imply that there is no causal relationship. Please understand that. Okay. Please see the following charts and give your comments. Forecasting of return of reliance. forecasting of return of reliance with Sensex. What we observe. Any one of you would like to say? Yes, many of you are saying that second model is giving me better forecast because error terms are reduced. So by including Sensex in the prediction of reliance, if the prediction improves, then I will say Sensex Granger causes reliance. Okay, so that what I mean when I say that the X will Granger causes Y if knowledge or information about X improves the forecast of the Y. Please note that Granger causality is a probabilistic way of knowing causality. Okay, what is it probabilistic causality means? Suppose you have a ball in your hand, you throw it up, what will happen? You will say natural. Obviously, it will fall to the ground. Will it be happening always? The answer is yes. That's a deterministic relationship because of the presence of gravitation in the earth. Okay, but Granger causality does not give you that deterministic relationship. It may be true in some cases, it may not be true in some cases, but there is some precedence of X over Y. That only it says, nothing else. Okay, Granger causality may be related to the idea of cause and effect, but it does not necessarily mean cause and effect relationship. What we can know from Granger causality is whether a particular variable comes before another in time series or not. It only suggests precedence of one variable over the other, nothing else. Okay. Uh, this is asking that if there is no Granger causality, then can we still use it in forecasting? You can use it, but your forecast will not be improved. So why you make your model complicated? Have a simple model and have a better prediction. Uh, what is the role of the theory? Friends, whatever modeling you do, theory always play a role. Never undermine the importance of the theory. Okay, there are so many people. I think Simaji, are you there? And you can very well appreciate that why theory is important in modeling. I'm not going to talk about co-integration that you're going to talk about in the next. Okay, so let's say when I say causality between two time series X and Y, what does it mean? Granger causality, future value of Y can be predicted, better predicted with or with a small forecast error variance if current and past values of X are used. Okay, that's what is called a Granger causality. Then we have a concept of instantaneous Granger causality. Future values of y, that is t plus yt plus 1, can be better predicted if the future value of x t plus 1 is used in addition to current and past values of x. But this is difficult to establish because we do not have the future value of x with us. Okay, so this is not uh, uh, possible, it is not possible for us to have a proper estimation of instantaneous Granger causality. There is a feedback between x and y if x is causal to y and y is causal to x. So friends, you can have x causing y causing x, and if both are causing each other, then you have what is called feedback. Okay. So having understood the concept of Granger causality, let's apply the same, and please ensure that time series should be stationary. If the series are stationary, then we can make use of Granger causality. Otherwise, we cannot. If we have more than one independent variable, say y, x1, x2, x3, x4, then you can have a pair x1, y1, yx2, yx3, yx4. You have to establish Granger causality pairwise. Okay, that you can do. Uh, Many questions students are asking me, uh, can you apply Granger causality in the panel data? I say, I'm again repeating it, you cannot do that. If you want to do it, then you have to come out with the time series structure in your panel. Ignore the individual behavior. Okay. So let's go to eView and see how can we do in uh, Granger causality test in eViews. So friends, please open up your file and let me open up the. I think some of you are asking about Reliance and Sensex. So let's take this file, Reliance and Sensex file. Friends, we know that prices are not the stationaries. So we are working with the Reliance of Reliance return and Sensex return. So friends, please select both of them together, enter. So we get this series of Reliance and Sensex. Are you able to open up it? Okay, good. Then go to view, click on view. Then in this view, you will find an option, Granger causality. Click on it. And right now, let's ignore the legs. If you want, you can have 2 legs, 3 legs, that's your choice. But for the time being, I'm taking the default legs. That's 2. Okay, so that's the data which we get. I'm putting it on this slide. So friend, that's the result which we got. Okay, now you can see Sensex eViews is also using the terminology does not Granger causes reliance. So null hypothesis is no Granger causality, and this is being rejected. Reliance return does not Granger causes Sensex. This is also being rejected. So friends, what does it mean? It means reliance is impacting Sensex, and Sensex is also impacting reliance. So there is a feedback mechanism that exists between these two series. Okay, and I have shown you that if you use Sensex in your data for predicting reliance return, you get a better result. Okay, so friends, I hope this is clear to you. Any question? Feedback is bivariate causality, you can say. So there is causality, but that's bivariate, bidirectional. That's what feedback means. Okay, you can say two-way, you can say bidirectional, you can say uh, Masroor Khan is asking me, sorry, Mr. Masroor is asking, what if your series is not stationary? Make it stationary by taking difference. You can make the series stationary. Okay. Why to reject? Because this is almost equal to 0, less than 5%, and that's why we reject it. Okay. So questions about p-value, I'm sorry, these questions are too basic. We don't have much time to answer those questions about probability values. Okay, friends, let me take another file and see how we can work about it. Let me take, let me close this. File, open, foreign data work file. Okay, now let me take future and I think let me take Nifty and VIX file. Please open up this file. So we have Nifty, VIX. And friends, I'm taking VIX because I've already proved that VIX is stationary. And if you want to check the stationarity of VIX, you can do at your end. Okay, so VIX is stationary, Nifty return is stationary, both are stationary. Let's open it. And then we have view, Granger causality, lag 2 by default. I select this, put it on PPT. right? Now, VIX does not Granger causes Nifty return. See, null hypothesis not rejected. But Nifty does not Granger causes VIX. This is rejected. So we say that Nifty return is Granger causing volatility in the market. So it is the return that creates a volatility in the market. So there is a relationship. What is that relationship? You can explore it further. Yes, yes, Manoj, you are absolutely right. Thanks. So once we determine the dependence among the variables through Granger causality, we can develop a suitable model for our purposes. Granger causality tells the direction of relationship. Okay, and once you get that direction of relationship, you can make your model accordingly, and you know, and thereby you can study the data which you want to uh, for which to answer your research questions. Okay. uh, Marvin is asking, does Reliance really causes Sensex data? I think I don't want to indulge into that debate, because that will may take me to the area of finance. So please, let's restrict ourselves to the concept of Granger causality. Okay. So first approach was bottom-up approach, where we say that no relationship, that are null hypothesis, and then we make we reject our null hypothesis to prove that there is a relationship. Now let's see what is the second approach. In this approach, we assume that data generating process are not independent. They are related. Okay, so I can say that yt is equal to alpha plus beta 1 yt minus 1 beta 2 xt minus 1 plus error term. Suppose I take 1 lakh of the variables. Okay, so what is the assumption I'm making here? I'm assuming that x t is causing yt, and if beta 2 is 0, that means there is no impact, and if beta 2 is not 0, then there is an impact. So that the whole philosophy behind this top-down approach. First, you assume that there is a relation, make your model accordingly, and then you prove whether that relation exists, whether your assumption is true or your assumption is not true. Okay? And this takes us to vector autoregression model, which we say VAR. So you can have a yt as a function of xt, xt as a function of yt, and then check causality. So since you are having two regression here, so if you put in a matrix form, you will get a vector, and we have regression of uh, variable with itself and with other variables. Okay, that's why we call it a vector autoregression model. Okay, so let's begin with simple things. Two variable, 1 lakh, which we say as var1. That means lakh 1. Two variables. So run two equations where in each case one leg of the own and other variables are included. You see here y1, y2. So we have two variables y1 and y2. One equation in terms of y1, in terms of y2 we have another equations. Okay, and now you can understand the coefficients. This is normally distributed. Okay friends, if beta 1 2 is equal to 0, friends, can you tell me what is the impact of it? Surinder Jabim is asking me, is VAR non-linear model? No, it's a linear model. And the relationship we are talking about, that is also a linear relationship. Granger causality gives you linear causality. Understand that. Uh, yes, some of you said that if it is equal to 0, that there is no causality between y2 and y1. That means y2 is not Granger causing y1. Okay? If beta 2 1 is not equal to 0, what does it mean? Shakti, Shakti is using a term indifference. Don't do that. Indifference has a different meaning altogether. You say you at the most you can say they are independent, but don't use the term indifference. Okay, right? So a lot of people are saying that if this is true, that means y1 is Granger causing y2. If you are able to understand this, that means you can prove Granger causality by making use of VAR model. Okay, and please note that VAR works only with stationary series. Okay, so you can generalize it two variables with the p legs, and you will have this kind of system of equations. Okay, and you can generalize it. So I'm not going into it. Notations you can understand yourself. Okay, for a two variable system with two legs, we get the following VAR module. Two legs, leg 1, leg 2. Okay, 1 and 2. This is of second variable 2. So if beta 1 1 is equal to beta 1 2 is equal to 0, and it is true, then there is no Granger causality from y2 to y1. I think you understand it. Jitinder Kumar is asking, can we use t-test here? No, it's a joint hypothesis. You will find you can make use of f-test here and not the t-test. But if you want to test them separately, yes, you can do it. And most of the time we do separately. In If you are doing separately the test on betas, then t-test is used. If you test them jointly, then you have to make use of f-test or wall test. Okay. Sushil Bajaj, again, I'm saying I'm not going to talk about co-integration. Just wait. In the next session, you are going to have a co-integration where you can raise all these issues. Okay. Right. Let me take this. Variable 1, variable 2. Sorry, variable 1 with lag 1 and 2. If beta 2 1 is equal to 0, equal to beta 2 2, then I can say y1 is not Granger causing y2. That the basic crux of using VAR system to prove Granger causality test. Okay, I hope it's clear to you. So when you go into a VAR framework, you must understand what is that you are looking forward. Okay. So Granger causality, this is equal to 0. Test when y2 Granger causes y1, we test whether they are equal to 0. Similarly, for the uh, we can test in the other direction. Is this same meaning as our causal use of the word causation? The answer is no. Again, we have to use the terminology Granger causality. Here it means that we are trying to know whether lags of y2 useful in predicting y1. Okay. What is the purpose of making VAR model? To exploit the relationship among the variables to get better forecasts. Okay. And please remember, VAR is based on the top-down approach. VAR is based on the assumption that relations exist. Alternatively, you prove relation does not exist. So let's see how we can make use of EViews for VAR structure. Okay. Uh, many question. Somebody is asking question about ARDL. ARDL. Uh, ARDL is a model where you have one dependent variable. ARDL model does not deal with the system of equations. So if you have a large number of independent variables and you want to check Granger causality simultaneously, your ARDL model will not work. So you have to come back to the uh, uh, VAR framework. Okay. So in the same framework, if I use VAR structure, let's see how do we do it. So this I'm just closing. Okay, friends, are you able to open up this? You go to quick estimate VAR. You have to write the equation here, endogenous variables. And my endogenous variables are Wix and Nifty return. And by default, I'm taking 2 lakhs, but if you want, you can change that. And please remember, you have to select unrestricted VAR. Vector error correction model you will discuss in the next session. Okay. Then you say okay. And I just copy this to my PPT to get a better glimpse of the things. Now, friends, you can see it here. VIX has a relation with its own lag significant. And these bracketed figures are t values. Okay, look at this. Look at this. This is coming to be significant. So normally if t is greater than 2, then we reject null hypothesis. And you can see here we are rejecting it. Okay. Now what is the implication of it? Implication of it is nifty return Granger causes VIX, but with a lag 2. Is that clear? That means if I take 21st July VIX, then 19th July Nifty return has an impact on 21st July VIX. So Nifty impacts volatility but with a time gap, and that time gap is 2 days lag. Okay, right? If we see here Nifty VIX, both are less than 1, less than 2. That means VIX is not Granger causing Nifty return, but Nifty return is Granger causing VIX. So friends, whatever approach you follow, the bottom-up approach or the uh, top-down approach, the result will always be same. There will be no difference in it. Okay. Friends, let me take one more file, one more data set and show you how can you get the results. How do you get the Granger causality in that? So please open up a file and suppose this time I take future and spot data of commodity. Friends, I've already calculated D future, D spot to make the series uh, stationary. Here we have 3 sets of data: the future data, the spot data, and the volume data. So I select them one by one, right click on it, sorry, open it. So if you believe in a bottom-up approach, you will go to view Granger causality and do the testing. Now, I have more than two variables which I can discuss with you. Right, now you can see it clearly. Okay, look at this, not rejected. Look at this, not rejected. Look at this, not rejected. Accepted, accepted, accepted. What does it mean? D future does not Granger cause spot. That means future is Granger causing spot, but not the other way around, if you see here. Okay, let's take the volume. D future does not Granger cause volume. Okay, and please understand here, when I say volume, it was the volume of the spot and not of the future. Okay, so future has an impact on volume. Okay, D spot has a impact on volume. Okay, let me put it in a proper framework. We have a future, we have a spot, we have volume. Future impacting spot and volume, and they are having impact bidirectional. So there is a feedback in the future and the volume, and Granger causality between future and spot and future and volume. Friends, I hope this is clear to you. If you have any question, you can ask me. So friend, trust that you must be feeling comfortable with the concept of Granger causality. If you have any doubt, any question, let me know about it. Okay, friends, let me do the same exercise before we wind up. Let me do the same exercise through VAR. So go to quick estimate VAR, variables, we have D spot, D future, D volume. Friends, are you with me? Pulvinder Kaur is asking me, can we apply in economics? In fact, the whole idea of Granger causality comes from economists. So the first application was in economics. Yes, you can do it. You can take macroeconomic variables and find out. So for example, money supply and inflation, you can have the Granger causality test in that. Uh, Deciding about lag, you can make use of information-based criteria, and I will show you how do we do that. Okay, right. Isha is asking me, Granger causality test, the first test is in making the model. Normally, yes, but if you are interested only studying the, the flow of direction or the relationship only, then Granger causality test will be sufficient itself. So friends, let's go to VAR. Quick estimate VAR, unrestricted VAR, write down the variables as endogenous variables. And that the result which we get. Now friends, you can see here D spot. Sorry. D future. Look at this figure. Sorry. Look at these future values. I don't know why this is not working. Look at these values. So you will find a spot is being impacted by future and volume. Clearly reflected here. And friends, here you are given the information based criteria, and on the basis of this you can decide the lags. So somebody was asking me, how do we decide the lags? By looking at the information criteria, you can decide how many lags you should have. Okay, right. D future, you see nothing is coming to be significant here. Volume, spot. Look at this. Uh, Not significant, not significant, and this is coming to be significant, and this is coming to be significant. This is coming to be significant. Sorry, volumes. So by going through VAR also, you can determine the cause and effect relationship by studying the coefficients together. Okay, right? So friends, that's all I want to discuss in this particular session. Trust that you must be feeling comfortable with the concept of Granger causality. And if you still have a question or a doubt, you're most welcome. We don't have any concept of long run and short run in context of Granger causality, but that concept you'll find in the co-integration, which you're going to discuss in the next session. Uh, Decomposition, I think Mr. Miklesh is going to talk about when they are going to talk about uh, the co-integration. So there you can understand the impulse response function and your variance decomposition. By looking at the t value, you can get an idea about the p value. You can also calculate yourself by looking at the probability t tables. If you take a leg of 3, no issue. You can have a t minus 1, t minus 2, t minus 3. You can take as many legs as you wish, but taking too many legs will make your models very complicated. So be careful, make your simple, make your model as simple as possible. Palak, normally you will find if T is two, it's some kind of a benchmark, you can say, which is normally work. A lot of questions are coming about CAPM, and CAPM has its own different methodology, and there we do not talk about Granger causality and things like that. There you have to make use of the theories of underlying theories of the asset pricing, and accordingly you have to make your models. Palak Jain is again asking me, should we check Granger causality before VAR? No, VAR itself can help you in determining Granger causality. VAR model, every coefficient has its own hypothesis. I can show you. All coefficients are having their own respective hypothesis, and the hypotheses are betas are equal to 0. We don't have any overall hypothesis. We have a individual hypothesis for betas. Okay. There is a question why double arrow had between spot and volume to show that there is a bidirectional relationship, as you can see from here. Sorry, I've deleted that. Okay, friends, I'm stretching too much, and I think you must have enjoyed it. Thank you very much. Have a good time. Enjoy the second session on co-integration. Thank you very much. Thanks a
Thank you,
lot.
sir.
Thank you.
Thank you, sir. Thank you so much. It's a privilege to have you with us.
Thank
It
you.
was a great learning in the simple ways, Granger causality, and many other concepts. Thank you, sir.
Thank you, Anshika. Thank you. Thanks,
Uh,
everyone.
Thank you, sir.
Thank you, Purushottam.
Purushottam, sir, when to resume? It's
12:15. Keep it 12:15.
12:50. Okay. All the participants are informed that the session will resume by 12:15. Please join by 12:10
And
or don't leave it.
Anshika, please inform Miklesh about
Yes,
this
sir.
time.
Yes, sir. We
Do you
do.
have his number?
No, sir. I asked Anjali ma'am.
Okay, do that.